In this lecture, we talk about two things: rectangular coordinates and graphs, and circles. So let's start with rectangular coordinates. Imagine that you have two sets, x and y, and let's represent these sets with Venn diagrams. So this is the set x and this is the set y, and we have some elements. Let's call these elements of x a, b, and c, and the elements of y 1, 2, and 3, where a is related to 1, b is related to 3, and c is related to 2. Here, as we can see, we have some relationship between elements of x and elements of y. So we have a relationship. This relationship assigns each element of x with one element of y. So we have a is related to 1, b is related to 3, c is related to 2. Now we can write this using what's called ordered pairs. We can write them as ordered pairs. So this can be written as a1, a comma 1. A comma 1 means ordered pair that consists of a and 1. A is related to 1. And b is related to 3. That means we can write b and 3. Also, we have c is related to 2. These are called ordered pairs. And we call them ordered because a is related to 1, but 1 is not necessarily to be related to a. I mean, it's the order is important. A1 is different from 1a, as we'll see when we define rectangular coordinates. Now, when we deal with numbers, sets of numbers, we usually need to represent them using some coordinate system, and the coordinate system that we usually use is the rectangular one. So when we have some ordered pairs like 1, 3, 3, 1, 2, 4, 0, 0, negative 1, 4, and we want to represent them using the rectangular coordinates. So we have x-axis and y-axis. Here we have 1, 2, 3, 4, negative 1, negative 2. This is the scale that I chose. And as you know that there are infinitely many numbers, real numbers between 0 and 1. This is 0. This is the origin. And between 1 and 2, between negative 2 and negative 3. So there are infinitely many numbers, but we usually use this scale. But as you may understand from this, you can use any scale. You can divide it into twos. I mean, 2 and multiples of 2, 2, 4, 6, etc. Here we have negative 1, negative 2, negative 3. This is the positive y, and this is y-axis, and this is the negative y-axis. This is the positive x-axis. This is the negative x-axis. Okay. And this point here is the origin, which is 0, 0. Okay, keeping this in mind, now we can represent these points, order pairs, in the number line or in the rectangular coordinates. So we have 1 3, 1 on x and 3 on y. So 1 step on x and 3 on y, so that means this point is 1 3. The second one is 1 step on x, 3 steps on x and 1 step on y. 3 steps on x, that means here, and 1 step on y, this point here. So this is 3 1. As you can see, 1 3 is different from 3 1, and that's why we call these this representation of elements from x and y, these relation shape between elements of x and elements of b, we call it ordered pair, or we call each pair of these ordered pair because order doesn't matter. Now let's graph 2 4, 2 on x and 4 on y. That means this point here. 0 0 is the origin, this is 0 0, and negative 1 on x and 4 on y, negative 1 and 4, this point here. Okay. Now, if we are interested in finding the distance between any 2 points on the plane, or this is called a plane or rectangular coordinate, if we want to find the distance, this distance between those 2 points, 1 3 and 3 1, let's call this P and this point Q. So what is the distance between those 2 points? So distance between P and Q is square root of x1 minus x2 squared plus y1 minus y2 squared, where this is x1 y1 and this is x2 y2. Now we want to find this distance. This is square root of x1 is 1 minus x2 3 squared plus y1 is 3 minus y2 is 1, and this is square root of, now 1 minus 3 is negative, 2 squared is 4 plus 3 minus 1 2 squared 4, this is square root 8. So this is the distance between the points P and Q. So we need to remember this formula. This gives us the distance between any 2 points in the rectangular coordinates, or on the plane. Now, if we are interested in finding the midpoint, I mean the point here in the middle of this line segment. So the midpoint of the line segment that connects A and B, or PQ, the line segment PQ is sometimes written in this form or using this notation, is x1 plus x2 over 2 and y1 plus y2 over 2, and this should be an ordered pair. So let's do this for our point. P is 1 3 and Q is 3 1. Now let's name these points. This is x1 y1, this is x2 y2, and then we find the midpoint. The midpoint is x1 plus x2, I mean 1 plus 3 over 2 plus now y1 plus y2 over 2, and that's 4 over 2, 4 over 2, this gives 2 2. So the midpoint here is 2 2, as you can see, 2 and 2, this gives us the midpoint. Now we know how to represent points using on the number or on the rectangular coordinates, and how to find the distance between any 2 points, how to find the midpoint of a line segment. Now one of the applications is the following. We want to determine whether the points M negative 2 5, N 12 3, and Q 10 negative 11 are the vertices of a right triangle. If they are vertices of a right triangle, that means this squared plus this squared equals the hypotenuse squared. So let's do this. Let's determine these points. If you look at the number line or the rectangular coordinates, the point -2, 5, say here, it's here, and 12, 3, this point here. This need not be accurate because we will not rely on the locations of these points, but rather on the computation. 10 and -11, let's say it's here. Now we have a rectangle. We want to see if this rectangle right angle. So to do so, we want to first determine the points M, N, and Q. We find MN, the length of MN. This is the distance between M and N. So this is x1 minus x2, -2 minus 12 squared, plus y1 minus y2 squared, and this is square root of -14 squared plus 2 squared. This is square root of 200. And the distance, I should write this using the notation that I presented above, MN. This is the distance between MN. Now the distance from N to Q is 12 minus 10. This is the difference on X, and 3 minus -11, the distance on Y. This gives square root of 200 as well if we compute this. And then we find the distance M and Q. This is -2 minus 10 squared plus 5 minus -11 squared. So we had MN, NQ, NQ was, let's compute it here. We have 2 squared plus 14 squared. And this is 4, this is 196, so it's 200. Now MQ, we have square root of -12 squared plus 16 squared. So this gives us square root of 400, which is 20. Now let's check. This is the hypotenuse, the length of this. Now NQ is square root 200 and MN square root 200. Let's see if this squared plus this squared equals the hypotenuse, which is 20 squared, then these represent vertices of a right triangle. So we have square root 20 squared plus square root 200, squared. Now when we square, we just cancel the square root. We get 200 plus 200, which is 400. Now this should be equal to square root of 20, it's a 20 squared, square of this. So this is 400. That means the left hand side is equal to the right hand side, and we are they represent vertices of a rectangle or a right angle triangle. Okay, now if we want to show that some points, 3 points, are collinear, then we need to see if the sum of 2 of them gives the distance between, if you have 3 points, these 3 points are collinear. If this distance plus this distance equals this distance, then they are collinear. You can apply what we learned in this section to determine that. So for example, if we want to determine whether the points P, which is -1, 5, Q 2, 4, and R for -10 are collinear, so we find first the distance between P and Q. So distance P and Q is square root of, this is x1, y1, this is x2, y2. So -1 minus 2 squared plus 5 minus 4 squared. And this is square root of -3 squared, 9, plus 1 squared, which is square root 10. Three, 9, and 5 minus -4. This is -4. So we have 9 squared, which is 81. So we get square root 90. And if we simplify, we get 3 square root 10. Because 90 is 10 times 3 is times 9, and we have square root 10 times square root 9. Square root 9 is 3, so it's 3 square root 10. Now we find distance between Q and R. So this becomes x1, y1, and this is x2, y2. So we apply the distance formula. We have 2 minus 4 squared plus -4 minus 10 squared. Negative 10. Negative is positive, so we have square root of 4 plus -4 plus 10 is 6 squared, 36. This is square root 40, and square root 4 is 2 square root 10, because 40 is 4 times 10. This is under square root 4 times square root 10. Square root 4 is 2. Now we have distance from P to R, from the first point to the last point. This is square root of -1 minus 4 squared plus 5 minus -10 squared. Now this is square root -5 squared, 25, plus 15 squared, which is 225. This is 225. So we get square root 250. 250 is 25 times 10 under square root. Square root of 25 is 5. Square root of 10. Now let's see. Now if we add this to this, I mean from P to Q, this distance is 3 square root 10 plus. Now this distance from Q to R. Q to R is 2 square root 10. This gives 5 square root 10, and that's equal to this, the whole distance from P to R. That means they are collinear. Now that was the first section. The second section is about circles. Now circle is a mathematical object that's determined by a center and a radius. So if you give me a center and a radius, I can draw a circle. And the center is given by hk and the radius by r, and the equation that we need to remember is x minus h squared plus y minus k squared equals r squared. So this is the equation of a circle centered at hk with radius r. Now this formula is called center radius formula for the circle, for the equation of the circle. Now a special case is when the center hk is 0, 0. If it's centered at 0, then we have h is 0, k 0. The equation becomes x squared plus y squared equals r squared. And this is sometimes called standard, the equation of the circle in the standard form or the standard case. Now let's take an example. We want to find the center radius form of the equation of the circle centered at -3, 4 with radius 6. Now centered at -3, 4, this is h, this is k, with radius 6, this is r. Now we try to write the equation. The equation is x minus h squared plus y minus k squared equals r squared. Now h is -3, so we have x minus -3 squared plus y minus, what is k? K is 4 squared equals r squared. R is 6 squared. Now negative is positive. X plus 3 squared plus y minus 4 squared equals 36. This is the equation of the circle in center radius form. If we want to sketch this circle, we start with the center. The center is -3 and 4. -3 and 4, let's say here. And then the radius is 6. So we add 6 here, subtract 6 here, add 6 here to 4 and subtract 6. So we get this circle with radius. This radius is 6. Now how to find this point here? We add 6 to -3 to the x. So that gives 3, 4. If we want to find this point here, we subtract 6 from -3, we get -9, 4. If we want to find this point here, we add to y, to 4. We add 6, we get -3, 10. And if we want to find this point here, we subtract 6 from the height. The height is 4, or the y-axis is 4. We subtract 6, we get -2. Sometimes the equation is not written in the center radius form. Now, how to find? We know that if the circle is written in the center radius form, then it becomes very easy to find the center. The center is just hk, and the radius is r. But sometimes the equation is not written in that form. For example, it's written in the general form. The general form of the equation of the circle is x squared plus y squared plus dx plus ey plus f equals 0. Okay, now if we are given this form, it's not easy to find the center and the radius. So we need to convert from this form into the x minus h squared plus y minus k squared equals r squared. I mean, we need to convert from the general form to the center radius form. How to do that? We need to use the technique that we learned before when we solved the quadratic equation. The technique is called completing the square. So here, by completing the square, we can convert from general form to the center radius form. let's take an example. If we have x squared minus 6x plus y squared plus 10y plus 18 equals 0, this equation is not written in the center radius form. So how can we find the center and radius of this equation, or how to prove that this is the equation of the circle? Now we need to complete the square, so we take we group the x term, the terms that include x, and then the terms that include y, and then we bring the constant to the right hand side, we change its sign, and then we complete the square. How to complete the square? If you remember from previous video, we multiply the coefficient of x, I mean b, this is b, and the coefficient of x squared is a, so we multiply b by 1/2 and square it. So 1/2 times 6, and we don't need to worry about the negative sign because we are squaring. So that means that will cancel the negative sign. So 1/2 of 6 is 3 squared is 9. Now we add it here and to the right hand side. Same thing for the y's. So 1/2 times b is 10 squared, half 10 is 5 squared is 25, and then we add it here and to the right. So this gives us x squared minus 6x plus 9 plus y squared plus 10y plus 25 equals negative 18 on the right hand side plus 10 plus 25. Now this is a complete square, so we can write it this way. X, the first sign is negative, or the middle sign is negative, and the square of 9 is 3 squared, plus y, the sign of the midterm is, or middle term is plus, and the square root of the last term is 5 squared. On the right hand side we have 16. If we compute this, we get 16. And then we have this equation. This is the equation of the circle written in the standard form. So what is the center? The center is hk. H is 3 and k is negative 5, because originally we have negative sign and negative 5. This gives negative 5 for k. Or you just change the signs of these numbers. If it's negative, we make it positive. If it's positive, we make it negative. And the radius is the square root of 16, which is 4. Now the last example, we want to show that the equation x squared plus y squared minus 6x plus 4y equals negative 12 represents an equation of a circle. So we need, this is not written in the standard form, I mean in the circle center radius form, so we need to convert it into that form. So we have x squared minus 6x, we group them, plus y squared plus 4y, and to the right hand side negative 12. And then we complete the square. 1/2 of the coefficient of x, which is 6 squared, this is 3 squared, which is 9, so we add it here and here. And then same thing for y squared. So 1/2 times 4 squared, 2 squared is 4, and we add it here and here. So we get x squared minus 6x plus 9 plus y squared plus 4y plus 4 equals negative 12, and we have 9 and 4 added to it. Now this is a complete square, so we can write it as x minus square root of 9 is 3, and the square becomes here, plus same thing here, y squared, square root of y squared is y, the sign of the middle term is plus, and square root of 4 is 2. And on the right hand side we have negative 12 plus 9, that's negative 3 plus 4 is 1. So the center is 3 and negative 2. We just change the signs of these numbers. And radius is square root of 1, which is 1. Now this represents a circle, an equation of a circle.